Today's learning goal is I can calculate the mean absolute deviation from a given set of data. A lot of times we call this MAD. M-A-D. Okay? I call it MAD because it makes me mad to do this. Okay? It's not my favorite thing to do. It's not hard if you follow the formula, but it can be a little annoying. Okay, what are other ways we can use mean? Okay, so we can use mean in sports to calculate an average score. Teachers use mean to calculate your average in classes. There's lots of different ways that we use mean or average. Okay, one of the ways that we can do this, again, they're going to show us with some math scores here. Okay, first thing that we should do when we get a set of scores like this, especially if we're looking to find the mean, the median, the mode, and the range, is to put them in order. I think it's the easiest way to add them. Okay, again, when you're calculating the mean, you're going to add these up and then divide them by the number of scores. There were 1, 2, 3, 4, 5, 6, 7. So when they were done adding them up, they divided by 7. Writing with the highlighter. And they got the mean of 83.3. Next, they found the median. The median is the number in the middle, which it's obviously 82. The mode is also 82. And the range is the highest, 95, minus the lowest, 72. Next, we're going to calculate the mean absolute deviation. Okay, to calculate the mean absolute deviation, you didn't really have to do all 4 of these ones that they showed us above. You really only need the mean. The mean is the thing that we need to calculate mean absolute deviation. So first you calculate the mean, which we did. It's 83.3. Then find the distance each of the pieces in the data are from away from the mean. So for example, our first piece of data is 72. We're going to do 72 minus what we got for the mean. No matter what it is, we're always going to make the number positive. So if it helps, subtract the other way. So when you do 72 minus 83.3, even though we should get a negative answer, we're going to just make it positive because distance is always positive. So we do that with 72, then we do that with 76, then we do it with 82, then we do it with 82 again, then we do it with 86, 90, and 95. We subtract 83.3, and whatever our answer is, we make it positive. So now we have a whole bunch of positive answers here. Now we take all the differences and we add them together. And then again, we divide by 7 because there were 7 numbers that I'm adding up. And my answer is approximately 6. This tells me that each of these pieces of data, the average each piece of data is away from the original mean is about 6. So it deviates about 6. This helps us tell how far the numbers are spread apart. Okay, given an average, if we find the MAD, this tells us how far the data is spread apart. And this data isn't spread that far apart. Okay, let's say he ended up failing one of the tests really badly, and he ended up getting, let's say, a score of a 42. Okay, our MAD number would be higher it would say that his data is spread out more. Okay, but his data only is spread out by 23 points. So again, you'll notice that the MAD is 6. Again, the more spread out it is, the higher your MAD will be. The less spread out, the closer or the smaller the number your MAD will be. And you can use this to help look at different averages and sets of data. You can try the Your Turn page, and then we'll go over that in class tomorrow. Good luck. Don't get mad while you're doing it.